Hi guys, welcome to the recommender system for Python part 2 lecture. In the previous lecture, we read the data in data frames and then we did some pre-processing and then after that we did some exploratory data analysis. So now we have a very good understanding on our data. Let's move on to develop a simple recommender system that can recommend similar movies to the user. To start with, let's check the head of our data frame once again. So df, head of data frame df. So we have user ID, movie ID, rating, timestamp, title, and the type of that movie. So to move on, let's create a matrix that will have the user ID on one axis, say along index, and the title on the other axis, say along column. So each movie will get its own column, and along the index we will have the user ID, where the value of the matrix will be from rating. So in this way, each cell will consist of the rating that the user gave to a certain movie. We are going to use title, rating, and user ID columns with pivot table command here. Let's do this thing and create a new matrix, which is the rating matrix df autocomplete with tab. If we check what type of arguments we can pass in, we have values, index, and columns. Let's copy these things from here. We can save some typing, and we are going to grab rating as value, user ID as index, and the movie title as our column. So let's run this cell and check the rating mat.head. So we have 9064 columns. Each movie got its own column. Lots of NaN. So lots of missing values. That is very common. So it's obvious if you don't have the rating for a movie from certain user, so that will appear as NaN with no value. So let's move on and check the most rated movies once again. And we know we have rating data frame. To get the most rated, we need to sort those values on number of ratings, and we can pass in ascending equal to false. This is our data frame. So these are the movies with ascending order. Let's display the head only. Let's display the first 10. So now these are the 10 top movies with number of ratings. We can grab any two from these 10 movies. We can grab, say, the first one with 341 number of ratings and the average rating of 4.05, and we can grab matrix with the average rating of 4.18 and it has 259 ratings. It is a good idea to check what type of movies they are. Let's grab the movies data frame now and check the title. When the title is equal to the name of the movie, we set the first one and we can pass this to movies again. This movie, Forrest Gump, is a comedy, drama, romance, and war type of movie. Let's check for the second selected movie, which is Matrix movie. We can simply copy and replace Forrest Gump to this Matrix movie. The Matrix movie is action and science fiction type of movie, whereas the Forrest Gump is a comedy drama movie. So let's grab the rating column from all the users for these two movies. Why we are going to grab the ratings column for these two movies only? We want to develop a recommender system and we want to compare the user rating of these two selected movies to all other movies. So we need to separate the rating for these movies in a separate data frame so that we can compare, or we can find out the correlation between user rating of these two movies to the user rating of all other movies. So let's grab the user rating for Forrest Gump FG user ratings, and from which matrix we have a rating mat here that we recently created, and we want to get only for Forrest Gump, so pass in the name or the title of that movie. Let's do the same for matrix. We can pass in here matrix and the name of the movie matrix, the 1999. Let's run this cell. Now we have the movie ratings of Forrest Gump and matrix in FG underscore user ratings and matrix underscore user ratings. We can check their heads dot head, and we can check the head of our second data frame dot head. So we got the user rating for the selected movies. Now we want to know how these movies are correlated to the other movies in the data frame rating underscore mat. So the pandas has a built-in function core with, which compute the pairwise correlation between rows or columns of two data frame objects. Let's see how the user rating of Forrest Gump is correlated with the user rating of all other movies in the rating mat. We can get the values in a new data frame similar to FG, and we are going to call core with on our rating underscore mat data frame core with, and we are going to get a correlation with FG underscore. So the same thing we can do for similar to matrix and call core with on mat rating and pass in matrix user rating. So now we are going to compute the correlation of matrix movie to all other movies in our data frame. So we got the values here in similar to FG and similar to matrix. Don't worry about this warning, it's only a pandas warning. So let's display how the similar to FG matrix look like. So we have some NaN values in the data. We need to clean this. Before cleaning this, let's create a data frame for the data so that it looks better. We can call that data frame as core FG and use pandas data frame capability data frame and pass in the similar to FG, and we can say the column name equal to correlation, and then we can check the head of our data frame at the same time. So this looks much better now. So we got NaN values in our data set. We need to clean our data. If you recall, we have a function drop NA. We can use that drop NA here on core underscore FG to clean our data, and we can in place equal to true so that we get rid of all these values which are actually NaN, and let's display the head of this data. Now we don't have any value which is NaN, so this is our clean data set. Let's do the same with matrix. We can simply repeat all these steps. So copy this one, paste here, copy this one, paste here, and change this to matrix, and similar to once again matrix, and here again matrix. So core underscore matrix pd dot data frame, similar to matrix, column is again correlation, in place true, dropping all NaN values, and then displaying again the head of the data frame. Similar to matrix is not defined. There is something wrong. So actually we have with small m here. So this is similar to matrix with small m. Here it is. Now this is our data frame for correlation of matrix movie with all other movies, and the data frame is cleaned. So in the recently created data frames, which are correlation or core FG and core matrix, the index is the title of the movie, whereas the correlation column tells us how the user rating of that movie is correlated with the user rating of all other movies in the data frame. So in principle, if we sort our data frame by correlation, we should get the most similar movies to Forrest Gump and Matrix in order. Let's use sort values here, and we can try only one movie. Let's try correlation with Matrix. So let's try Matrix movie only, and sort values on correlation. Let's copy this correlation and paste it here. And we want ascending equal to false. So this is here. We have lots of movies, all of these movies in the correlation column. Let's display the head only. So here it is. It looks like all of these movies are perfectly correlated with the Matrix movie. There is something wrong here again. The result doesn't make much sense. We need to fix this, and we know what is the problem. If you remember, most likely these movies are watched only once or twice by the same user who also watched Matrix, and he or she has rated Matrix and these movies with equal stars or maybe 5 stars both movies. So to fix this, we can set a threshold value for the ratings. Let's replot a histogram for number of ratings to see which could be the good threshold value for number of ratings in our data frame. So we can use plt dot hist, and we can grab rating and then n rating column, and let's say we want bins equal to 50 here. Let's plot how the plot looks like. So we see that the drop is significant somewhere around here, maybe somewhere around 50. So for n ratings equal to 50, we get a significant drop. We can set the limits along y-axis just to expand this as well, but it looks fine here. So we can select 50 as a minimum number of ratings in order to be considered into our recommender system. You can play with the different numbers, say n equal to 30, n is equal to 60 or somehow. We are going to set n equal to 50 here. Let's sort the values again with condition n ratings greater than 50. And also join the number of ratings column from rating data frame to core underscore matrix data frame. And then we apply the condition. In this way, we will be able to see the number of ratings and correlation both in the same data frame. So core underscore matrix equal to core underscore matrix dot join. We're going to join rating, and we have n ratings column. And let's display the head of this data frame again. So now we have title, name of the movie, correlation of that movie with the Matrix movie, and then the number of ratings for the movie. So now we can use sort values to sort these with the condition where number of ratings is greater than 50. Core matrix, we need n ratings where n ratings is greater than 50, and we pass in this whole to our data frame core. I hope you still remember how to do the masking in the data frame, and here we are actually masking our data frame on certain conditions where the number of ratings are greater than 50 and sorting the values on correlation column, and our sorting is ascending false. So here it is. These are all the movies along with their correlation and number of ratings. Let's display only the head of the data frame. So here it is. Now the results make much more sense. Matrix has the perfect correlation to itself, whereas the Star Trek is the closely correlated movie with Matrix. Another very important thing to remember here, lots of time the recommender system suggested really popular movie against the popular one, even if their type or class or category is not similar. You can repeat the same thing for Forrest Gump and see which movie your system is suggesting closest to the Forrest Gump. We can do this thing here again. So core underscore FG is our data frame. We can once again join the number of ratings from rating data frame, and then let's copy this here, apply this condition. But we have FG instead of matrix here. FG here, FG core FG sort values on correlation ascending is false, so we want highest to lower and then display the head. So here it is. So now we see our recommender system is suggesting that the closest correlation to Forrest Gump is My Big Fat Greek Wedding, and then Beautiful Mind, and then Few Good Men, and so on. So excellent work, guys. I hope that you have enjoyed the recommender system section. The next thing I want to mention, as I already told you guys in the beginning, that at the end of the notebook you have a couple of links. If you want to learn more about the recommender system, you can explore these links, you can download the data sets, and you can build your own recommender system. Keep it in your mind. This is very fascinating career for you if you want to move on with the recommender system career. Excellent work. See you in the next lecture. Good luck.